Now we want to take the derivatives of these three functions. And we do this using the chain rule. Now the chain rule says, and I'm using the prime notation, that the derivative of f of g of x is g prime of x multiplied by f prime of g of x. So, in the first example, our f of u was u cubed, so that f prime of u is u cubed prime, or 3u squared, where the prime is taken to mean the derivative with the default variable. There's only one variable here, that's u. Okay, the g of x function has derivative g prime of x, and it's very, here's the g of x function, it's pointing to this. The g of x function has very straightforward derivative. The derivative of the square root of x is 1 over 2 square root of x, or if you prefer 1/2 x to the negative 1/2, but be sure you can move back and forth between those two notations. And the derivative of x squared being 2x, we have minus 2x. Then we just put this together, okay? G prime of x multiplied by f prime of g of x. Well, the g prime of x is right here. We just write it down again, the 1 over 2 squared of x minus 2x. And then we have our 3u squared function for f prime of u, so that f prime of g of x is what? 3 times g of x squared. Now, g of x being square root of x minus x squared, we substitute that here. We bring the 3 out in front, and we get this expression in the most straightforward way. Okay, the second function, and we're just going to do the same thing. We've identified our f and our g functions, so it's just a matter of taking some derivatives. F of u is 3 over u, so f prime of u is negative 3 over u squared. Now that's something you should understand well by the time by the time of this class, having had plenty of homework over that during the last week. But just to be sure, because some people were a little hesitant, 3 over u means 3u to the negative 1, and then 3 over u prime is 3u to the negative 1 prime. 3 is just a constant multiple. We bring that out, and we have u to the negative 1 prime, of course multiplied by our 3. And the derivative of u to the negative 1 is negative 1u to the negative 1 minus 1, which is negative 1u to the minus 2. We bring the negative out here, we get a negative 3u to the negative 2, which is just 3 over u squared. So our g of x is x squared plus 5. Derivative very straightforward is 2x, so g prime of x is 2x, and now we're ready to assemble the derivative of our composite function, which is g prime of x times f prime of g of x. G prime of x, of course, is our 2x. There it is. F prime of g of x is what? Well, f prime of u is negative 3 over u squared, and it looks like I left a negative sign out here. Okay. F prime of u is negative 3 over u squared, so f prime of g of x, we've replaced u by g of x, so we have to replace u by g of x. And then we have the negative 3 over g of x squared, and I better put the negative in there and here. Okay. Then we substitute for g of x, just x squared plus 5. Remember, g of x was x squared plus 5. And we get 2x times negative 3 is negative 6x. G of x squared is x squared plus 5 quantity squared. Again, very straightforward. Once we've broken the function into composites, and of course when you're doing derivatives in different situations, you're going to have to recognize that you have a composite so that you can break it into its component, component functions. Okay, so here we have this function which has this f of u and this g of x. So f prime of u, well, derivative of 3/2 power is 3/2 times the derivative of the 1/2 power. F prime of u is thus 3/2 u to the 1/2. To make that prime a little more prominent, it was there, but it might have been hard to see. Our g prime of x is very similar to the g prime of x we got up here, a little bit of difference in the function, but it's straightforward to get that as 1 over 2 square root of x minus 3 from this function. And then our derivative of the composite function. Allergies, I don't know what's going on. I do know what's going on, allergies. Okay, g prime of x times f prime of g of x is what? Well, here's your g prime of x. There we got it. F prime of g of x, u is, g of x replaces u, so replace u here by g of x. We get 3/2 g of x to the 1/2. And then we substitute for g of x. We substitute our square root of x minus 3x for g of x, and we get this. And the 3/2, I've multiplied the numerator by 3 and the denominator by 2. And there's more factoring that we could actually do. The 1/2 power is the square root, so the 1/2 power square root of x minus 3x is the square root of what? Square root of x minus 3x. And we have the 3 here, the halves. You can do the arithmetic on that. So the process is very mechanical. The difficulty is not in implementing the process. The derivatives are usually, you have formulas for taking derivatives. And it's not something you have to be creative about. You just have to recognize your function and apply the formulas for the derivatives. In doing the composite, you just have to know that you're looking for g prime of x and for f prime of u. And everything works out very nicely. If you practice, of course, you need a little practice to understand what's going to happen next and understand why you're doing each step and where it's going to go. Again, as I mentioned, the difficulty in the process is recognizing in the first place that a function is a composite. You might have a bunch of functions, some sums, some products, some quotients, some composites of products or quotients. It can get very complicated, but if you follow the rules in a very systematic way, it works out. The algebra can get pretty terrible. But in this course, we're not going to get into the really terrible algebra. Okay, that might look kind of terrible, but it doesn't get a lot worse than what we see here.